Okay, solve for t. So they're giving us this equation. I'm going to make it an x actually because my t's look like pluses and it's hard to tell them apart. Let's make it an x. Same deal. So we're trying to solve for x. Notice x is an exponent, right? He's in the power zone. That makes this an exponential equation. So when x is up in the power zone, that's what we call an exponential equation. X is an exponent. What do we do? Step number one, we're going to put it over here. Step number one, get the base to the power piece alone. So that would require dividing both sides by 1,000. And so we get 1.18 to the x. Use your calculator. See, actually, we can just do this by hand. 32.2, right? Because it just moves the decimal back 1, 2, 3 places when you divide by 1,000. I don't know if you know that rule. So step number one, get the base to the power alone. See how the base to the power is alone now? We got rid of that 1,000 that was in the front. So the base to the power is alone. Step number one. Step number two, so we did that. Step number two, ln both sides. So we're going to take the natural log of both sides. You can actually do the regular log or the natural log. It'll work the same either way. It doesn't really matter. But I'm going to do it on both sides, right? Whatever you do to one side, you have no choice but to do the same thing to the other side to keep the balance, right? You gotta keep the balance. So I take the natural log of both sides. Now, it shouldn't be that this is a little surprising, but really it shouldn't be surprising. Why? First off, you might think, well, where'd the log come from? There was no log in this problem, right? There was never a log, and that's true. That's right. That makes it kind of surprising. Like, where in the world did the log come from? There's no log. This isn't a log question, right? But the deal is, to get this x out of power, the opposite of a power, the opposite of an exponential is a logarithm. Now we start to see why they even made up logs. Remember, all of math is made up. All of it. Every bit of math is made up to help us deal with things in the real world. And so specifically, logarithms were made up to be the opposites of powers, exponents. And so if you think about it, how else, let me go back for just a second. It's worth a second of our time. How else are you going to solve for x there? I mean, what are you going to do? I think it'd be worth it to just think about, could I divide? No, that's not going to work. You can't just go, oh, just divide. No, that's not x times 1.18. If it was, then I could just divide by 1.18 on both sides, and that would get it alone. But it's not x times it. X is in the power zone. That's different, right? X isn't multiplied by the 1.18. X is the power, right? That's totally different. You know what powers mean? Like you know what a third power would mean? It would mean, three of those, right? So an x power means x of those. It doesn't mean x times. That's totally different. So we can't divide. Well, how do we get rid of that one? Can we subtract? Well, you just laugh at that. You know we can't subtract. It's not added. Do you see the problem? How in the world are we going to get rid of that 1.18 so that we can find x, so we can get x alone? The answer is natural log. Why? Why would we think of that? Because logs are the opposites of exponents. That's what they are. They're the inverse functions of exponentials. So that's why they even made them up. They made up logs for this very situation because they needed something that was the opposite of a power. Why? To get that power out of power. Right now, the x power, step three, the x power drops down to the front. Remember that log property which said powers can drop down to the front? Remember that one log property? So now we do that. That's exactly what happened. Other side just stays the same. Now Now it's cake. Why is it cake? Because now the x is just multiplied. Now that the x is out of power, this is an easy question because it's just multiplication, right? This just means x times it. So now we can just divide. So then I'll just write and then divide. So then now you just divide both sides by the ln of 1.18. No big deal. Once that x is out of power, then it's not powerful anymore. It's just multiplying. So it's an easy question, and x equals, and then just hit the buttons on your calculator. Whatever that is, I have no idea. I'm gonna do it. Make sure you got to keep parentheses around the part in the top and then the part in the bottom separately. I'm getting, so watch out in your calculator, 20.9768. I don't know how many decimal places they didn't say. Oh, give an exact answer or 3 decimal places. Yes, that's good. I gave 4, so that's fine. So make sure when you put it in your calculator, you put parentheses around the first argument and parentheses around the second, and you will get it. So there's the step. So when you have x in the power zone, x in the exponent zone with an equal sign, an exponential equation, first off, get the base to power thing alone, get rid of that 1,000. Then ln both sides, and that allows the power to drop down, and then it's just multiplication, so just divide. And we got it.